Hello, in this video we're going to be looking at the relationship between classes and objects. So in particular we're going to look at how to define classes in Java, how to create objects from these classes, and how we can describe a class using a UML class diagram. And to do this, to demonstrate this, we're going to think about a circle. So what is a circle? Well, we all know what one looks like. It would look like that if I could draw better. So how do we define a circle? Well, the defining feature of a circle really is its radius. So the length of this. And that's really all there is to it. Everything else about a circle we can calculate. For example, we can calculate the diameter if we really wanted to, which is equal to 2 times the radius. We can calculate the area, which happens to equal pi r squared. We can calculate the perimeter, which happens to equal 2 times pi times r, and this kind of thing. So there's all this information that if we were writing a program that was working with circles, like some geometric software or whatever, these are the kind of things we'd want to know about a circle. But the defining feature of a circle, the one that we really need to know before we can derive any of this other stuff, is the radius. So what we're going to do now is think about writing a class that describes this circle in Java. So over in Eclipse, let's create a new Java project, and we'll call this circle test, and I'll add a new class. And what we'll call this class is actually circle. So this class, in Java, a class is kind of like a blueprint for an object. It describes the properties of an object, so in other words, the variables that it has, and it describes how it operates, its behavior, what methods that the object has, and what they do. So we're going to write a class that describes the circle we just talked about earlier. So what we're going to need is the radius. So we'll have the radius be a private double, and we'll call this radius. Pretty easy. And next up, we need to think about how our circle class is going to be used. So let's create a couple of constructors so that people using our software can create a circle. So public circle, a default constructor. What should the default constructor do? Well, it needs to set radius to something, but really, we'll just set it to 0 for now. More likely they want to use... Why is that complaining? Because I spelt radius wrong up here. There we go. Really, more likely what they want to do though is have a constructor which takes in the radius as a parameter. And what we'll do is set this radius. So this is kind of important. When we have a variable like this is a member variable. It belongs to, which means that any object we create has a copy of this variable, which means we can create as many objects as we like and they can each have their own radius. The this keyword basically refers to the particular object we're operating on now. So we'll see this a bit more when we do some testing. So anyway, there's a couple of constructors for our circle. What else might we need to know? Well, we might want to calculate the area and return it. So we'll have a method called getArea, which will return the area of this circle. Return, how do I say we do the area? We do math.pi multiplied by radius multiplied by radius. And that's how we do it. So we can calculate the area. What about the perimeter? Well, we'll write a method for doing that as well. Return 2 times math.pi multiplied by radius. So 2 pi r to get the perimeter. What else might we want to do? Well, we might want to update the radius of our circle. So let's write a setter for the radius. This is going to take in a double, which represents the new radius. And it's going to set this radius equal to the new radius. And there we go. So that'll probably do for now. What we should look at now is how we can test this. So what we'll do is create a new Java class, and I'll call this one circle test. And this method, this class will have our main method for doing some testing. So what we're going to do is create a couple of different circles. So circle C1 equals new circle, and we'll pass in 1 as the parameter. And we'll copy this 2 times, and we'll change these variables to C2 and C3. And let's set circle 2's radius to 25, and circle 3's radius to 125. So now we have 3 objects that all represent circles. They were all defined using this single circle.java, this single circle class, which describes the kind of things that a circle needs to be able to do. And now we've actually created objects that are circles, and each one has their own radius. So what we can do is test this out. So system.out.println, let's print out circle 2's radius. Not radius, area. So c2.getArea. We can also do this with, for example, circle 1's area. So we'll just change this. So let's run this and see what happens. Okay, so circle 1's area happens to equal pi because the radius was 1. And circle 2's area is some big number. So you can see how this is working. Even though each copy of our circle, in other words, each object has its own copy of radius, which is exactly what we want, because there's no point in having multiple circle objects and we can only define one radius. That's not useful at all. We can do similar things with the the perimeter. C3.getArea, and that'll return us circle 3's area. So if we print, what have I messed up? I can't spell print, apparently. There we go. So there we go, we've got circle 3's perimeter as being some big number there, 49,000. Well, that makes sense because the radius was 125. So, what should we do next? Well, let's look at how now that we've written our circle class and instantiated some objects, let's look at how we represent this using UML. So we can represent a class quite well and intuitively using a UML class diagram. And the way it works is like this. If we have a rectangle, okay, this is going to represent our class, and it's divided up into 3 sections. So the first, up the top we have the name of our class, which is circle. Next up, we have a middle section, and inside this middle section are all the member variables or the properties of our circle. So we had 1 in this case. We had a radius, which happened to be a double. So we have a variable called radius, and that's going to be a double. Okay? The bottom section is all the methods that are defined inside the circle. So we had 2 constructors. We had another constructor, which took in a radius, which was a double. We had get area, which had no parameters but returned a double. And we had get perimeter, which looked exactly the same. So I'm just going to say get per because I'm lazy and you don't need to see my handwriting. We also had set radius, which took in a double, which was the new radius. And that returned void. We should say that. So I've gone out of my lines, but that's okay. So this is what a UML class diagram is all about. We have the name of the class, the properties of the class, and all the variables, and we have the methods. So that's what a UML class diagram looks like. We also can have an object diagram, which is kind of like a simplified version of this. So in our case, in our test program, we created 3 circle objects. So we can draw an object diagram like this. We had C1, which was a circle, and the radius was equal to 1. We had C2, which was also a circle, with the radius equaling 25, and we had C3, which was also a circle, with a radius of 125. So in addition to being able to represent a class using a UML class diagram, we can also represent objects of that type of class. And in that case, all we need to know is the variable name, the class type, and what the actual variables were set to. Like that. So with that, that's really it for this video. So quickly to summarize, a class is like a blueprint for an object. It describes the data that an object contains, the methods it has, and therefore its behavior. An object is an instantiation of a class. For example, we created 3 circle objects, and each of these circle objects had a different radius, but they were all constructed using the circle class. Now we can represent classes and objects using UML class diagrams, which we've demonstrated just before. So with that, that's it for this video. Thanks a lot.